Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. I have close to 18 plus years of experience working in multiple MNCs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and Neuralink. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID, so please reach out to us and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you. So guys, there is a few keywords which we need to understand. One is transaction. Okay, transaction. Another one is trace, and another one is span. 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 Spelling mistake. So anyone who is having idea what is the transaction, what is the trace, what is the span? Anyone?
Business transaction where the calls are happening
Mm-hmm.
for the transaction and the traces how the calls has been traced, and span is a multiple endpoints call.
Mm-hmm. Okay.
Span is like event type, right?
Okay. So let's put it in this way. There's a conflicting definition is available on the Google also, but based on my understanding, I will just put it up. So here, this is one service, this is another service, and this is the another service. So here, this service is talk, and let's say this is the human talk to this service client, and this service will talk to this service. This service will talk to this service. So service A, service B, service C. Now the question is, what is transaction, what is trace, and what is span? So guys, once we get into this service, all of you are comfortable with the function, method, classes concept, right? How one function call to another function call to another function. Main class will call to the subclass, like that, child class. Are you comfortable with this concept, right? Hello?
Yes.
Yeah. So here, this is the main class, public static void main. Remember the main method? This main method will call some other child method. This child method will call child2 method, and this child2 method probably will call service2 or service B or something. Okay, so this you are comfortable. Now let me define what is span. So span basically, let me change the color. Span is basically internal to the service code. So one method called to the child method 1 C1 and C1 called to the C1 2. This is the, let's say, 1 second, and this is 1 second. So if you want to know between the span, basically one method to another method, how much time it was spent for the response. So right now 1 second, 1 second. So here the span is basically this one. There's one span, there's another span. So one span, two span. So overall, this whole service has been sending the response time in 2 seconds. Are you understanding what is span now? This is span and this is span. Make sense? Hello? Hello?
In between that time for the transaction is when?
In between the code itself, one code is calling another code within the same service. Those duration is called span. Okay. Now the overall this 2 second means how many span you have? One span and two span in this example. So that means this service will give you the response in 2 seconds. So that is a total response time. So now one service will talk to another service. This is called trace. Here there is a trace and this is called trace. So whatever that service one requests to service two, what is the response time? It's a trace. So that means trace is equal to multiple span. Correct now? Agree with me? Okay. Now last thing which we have is what is the transaction. So all the services which required you to serve your request. So multiple traces together. So here one and two. This is called transaction. So here if I put it up in a way, span transaction is equal to multiple trace and trace is equal to multiple spans and spans is equal to one response time of one method, one function to another. Understood? Understood?
Yeah.
So this is the one. So how can we visualize that? So let's look at this. So right now I have, if you look at this, I have only one service. So in real time, you will have a more service, 4, 5 service. Right now, only one service. So transaction, I'm not able to show you, but trace, I can show you here. Look at this. These are the trace, and you have got this one. Now each trace, let's look at this one trace. Okay, this trace is a one trace, and what is this timing for this? So this trace has served. Look at this 0.0
2
to
second.
2 second. Now you want to deep dive into the code level. So here this is the trace value is 2 second, but if I go to the span, so this is the what has happened. I call the sync and the sync call this method servlet dot dispatch. So how much time? So here you got a two span, and if you look at this, this servlet dot dispatch has offered you the services in only 564 microseconds, millisecond to microseconds. Look at this service dispatch. This is not multiple call; it's a simple application kind of hello world. So like that. Understood? Now, if you have multiple spans, here you can see that all this stuff and calling, and each of these you can visualize also. So real time, what will it will be there right now? It's a one call. If you have multiple calls, so you will see some different pictures like let me show you. So you'll see something like this one, this image. If you have a multiple call, hmm. So you'll see something like this image. Okay, so let me show you an example for it. So Datadog trace span image here like this. Look at this, visualize this image. Here they are calling multiple method actually. See multiple services, and you see that each one of calling other services method and all, and whole visualizations you have it actually. So which method, which class, which service has spent how much time for overall response, you will get a complete visualizations for it. Are you understanding, all of you?
This one, can you explain again, this figure?
Which one?
The current
This
UOPL.
uh, current though it's very simple though. Current one is very simple. Here you have only one call, and this call is calling on the functionality which I was showing you here. So go to span list here. DevOps
Span
full service call this async endpoint, async call internally servlet.dispatch, and
dispatch.
servlet.dispatch giving you response in 564 macrosecond. It's very simple. But in real time, if you have a production ready applications and all, so for that I was showing you, you will see something like this. And that way you will install the agent in every services and you'll have this visualization. Got it, all of you?
What is this orange, purple?
Which one? These are the
This
services, different calling, coding. This is, see, if you look at this one function to another function, another function, another function, these are the call actually happening internally.
Okay.
So here MongoDB is there calling, here Mongo queries. So these are internal calls for the each services.
So if in third row, if you come from bottom, okay, corner side something red is there. What is it?
This one, red.
Here. Yeah, and here also.
So here there is a response time. Probably that alert has been triggered actually, maybe because of alerting. I'll talk about it. That one. So alert has been triggered. That means this is a important transactions and it has some errors or something like that.
Okay.
So like that. So guys, this concept you understood that. I hope you'll always remember that transaction, trace, and spans. Correct now? Okay, so now let's look at this here. So you have your job is to understand this all graph and troubleshoot. Remember that your goal is to find what? What was the your goal? What was your goal objective in APM?
Find out the
Find out the
performance, latency, everything like, yeah,
find out the trace. Find out
traces.
the trace which has a response time more than your threshold and troubleshoot that. Why that? So look at this here. There's a trace actually, so much of trace. Unfortunately, I have everything is 2 seconds, but you have to assume that okay, this is the trace which is consuming the time. So now everything you have at one place. Look at this. Every for this trace, assuming that it's taking too much of time, and assume that there's an error also. So you have to troubleshoot. Now you will see all the calling functionality here, spanning list and all, right? And you will see the code level information. You will see the map, service map. Service map means one service call to another service. Right now there's only one service I have, but let's say service one will call to another service. So nice map will be created. For example, service map Datadog image, something like this will be created like this. Okay, so once you have a real time, then you will have a this service map will be created here. Okay, so now what is the information about this service? So here you have info. Okay, what is the infrastructure matrices? Here you have all the infrastructure matrices. Logs I have not enabled, metrics we have enabled. So infrastructure we have, process I think I have not enabled, so you don't have it. Logs I'll do that tomorrow, so you'll have it. So every place, everything you will get it here. Trace information, APM, infrastructure, matrices, processes, network, logs, everything. And codes hotspot is very costly. Costly means in that way it is. You can see the code also actually here. Code also. Which code is running and which code is taking, but it required lots of CPU and lots of RAM. So this is a special scenarios when you enable it. Sorry. So that is the stuff. So yeah, sorry. So each each trace you can troubleshoot. Now if I click on the services here, you have a durations to select the data for. So right now it's 1 hour. Left side you have a different filters available. So primarily there are four types of services you will have it. One is web services where the web server is there, database services, cache services, function lambda, and custom services. So right now you see the web, you have a web services. You can make it favorite also, because in real time you'll have a 200 services, 300 for one product. Okay, you can see the summary deployed last deploy 3 hours ago. What is this last deploy? That version 1, version 2, you can see that here. Here request 0.6 requests per second, latency and infrastructure and monitoring. Here you can see that in this. Click on this DevOps tool. Now you can filter by environment. So right now I have only one environment. Prod you may have it. You can filter by the types of applications, and you can filter by the versioning. Do you remember the 1.0, all of you? 1.0, do you remember that?
In Catalina, what you said, like, no?
Yeah. So now
Somewhere.
time, yes. So now time has come for, shutdown, Tomcat, shutdown dot sh, and time has come for updating 1.2. I'm not changing the software, but assumptions just assume that you have changed the software also. And then Catalina dot sh, and here 2.0, mind it here. So, and then startup. Okay, and done. So yeah, now within a few seconds you see the version 1.1 anyways is here, and then 1.2 you also you get it. Just wait for a few seconds more. Okay, so now here you have a service summary that I'll minimize it right now. Now let's try to understand all this work. So here you have a resources, here you have a deployment, here you have a error tracking, security, infrastructure, JVM metrics, profiling, traces, and all stuff like that. So let's start understanding all this stuff one by one. So, and the service summary, you have these are the summary, these are the latency and stuff like that. Here you have errors, here you have a dependency map, and all this stuff. So one by one, this is a summary page. Let's understand. So if you see it carefully, this graph, spend time. Okay, spend time. Now see that here, it's very simple, request and errors. So here you have a total request, this is the time, and if you have errors, hits and error, there's a few errors here, you can see that, right? Now here if you see that, the moment you read it little carefully, not ignore it, you will see that total request in 1 hour. So my window is 1 hour here, top, look at this. So total request is 1 hour, 2.29k total request, and out of which their response average is 0.6 requests per second. Now if you see the three this icon, you will see that for every graphs in APM. This is for enlargement, this is for creating incident if you find something wrong here, and then this is for multiple options like copying the logic and copying the graph, copying it to the dashboard and all many things. You'll see that. So let me show you here. This is the full screen. This is, you see, copy, share snapshot, add this graph to the incident, add this graph to the dashboard, add this graph to notebook. Now notebook is basically, here we have a run book. Okay, and here if you see declare incident. So each graph you'll see under EPM, these are the three options. Now you know what, this you can play with it, drag drop using mouse. That is also you can do that. Okay, so automatically every other time series will be pre-populated. So remember that one also. So I'm looking for 1 hour. So here request an error. Here you have a request y version. Now, did you notice something version has come? So if you say me which version is good, so here 1, this is, and this is 2. So here, if you look at this here, that little confusion in the things, but right now if you see that, so if you see that 1 versus 2, 1 was here and 2, there's no much difference actually if you look at this, correct now, because 12 hits per second per minute, I think, for that time for second actually, and here also 12 hits. So it's a concept because JMeter is hitting that one in the background. So you can compare between the 1 and 2, and now here you can filter 1 and 2. So request by version, request per second by version, this is information. You see that there's no much difference here. And here request and errors per second, here you have it. So let me close this. So here you have a hits total, and here total errors. So that way you can see that. So that way 1 hour of data, how much you have got the request by version, request and errors per second, and request per second by version, all this data you have it. Are you okay with it, all of you?
Yeah, you have to see.
Yeah. Now here you have few things. One is latency. So if you carefully look at it, let me highlight the latency. Okay. So if you see that latency, you have P50, P75, 90, 95, 99, and here you have a second, and this is the timing, and this you can see the latency like this. So what exactly latency? What is the meaning of P50 or P99? So P means percentile, okay? But question is what exactly that is, and how it will help us in order to understand the performance of my application. Anyone have a clue? Anyone would like to help me out here? Anyone? Hello?
Yeah, here, I feel it is normal, right?
It's a normal right now, but what is this percentile concept?
Percentage 50.
So this is a something like it's this concept we have in the CBSE board also, right? We don't get a number, we get a percentile. Correct now?
Grading system.
Huh. Yeah. So what is percentile? Okay. So let's understand this way through the simple formula. Where's my slide? My slide is here. I'll not go through too many slides on this. This will help us. So guys, all of you can see my screen, right? Slide screen.
Yes.
I would like you to spend few seconds before me explain it to you. So just read it and try to understand the percentile in your own way, and then anyways we'll discuss. Yeah. So can you help me to understand? Did you understand now percentile?
No.
Okay. So understand this very simple way. Okay. So here what is happening? Let's say for 1 hour, okay, you got a total request 100. Okay. So here you see 5 plus 5, 10 plus da 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 with this all things will come into 100. Okay. Now what tools is doing in order to find out the percentile? Now they will bucket it out. So here they will say, okay, I want to know list of requests which got processed in 1 second. List of request which is processed in 2 second. Response time 3 second, 5, 6, 7, 8, all stuff like that. So this now you understood this table, all of you.
Yeah.
Okay. Now when I say hey, give me the P99, what does that mean? So this is the 1%, this is the one benchmark you can say. So when you say P99, so here 5 to 4, if you see, this is the 99. So that means your P99 is 7 second. Okay. So this is the 7 second. That so now you will ask me, Rajesh, what is the meaning of it? So P99, when I say, hey, P99 is 7 second, that means 1% of your overall traffic is having response time more than 7 second. And that could be 8 also, 9 also, 10 also. Correct now? So that means they will ask you to
Say it
focus on,
again, Rajesh.
yeah.
More what you said, the last statement.
I said like if you say P99, that is benchmark is coming 7 second. So that
Okay.
meaning of this is that means 1%, which is remaining 1% of traffic people who is having the response time more than 7%. Correct now? More than 7%. Here this is the 1% and this is the 8 second, or it can be 9 also, it can be 10 also. Correct now?
Hmm.
Hello?
Oh, I think it's not percentage, right? It's seconds, correct? It's taking longer duration.
That means what I said, P99 is just 7 second as per this table. That means 1%, remaining 1%, P90 meant percentile 99. That means 1% of people which is remaining is having response time more than 7 second. That is the logic. So that means you need to focus why this 1% of people is having response time more than 7 seconds. Okay, so you can find out. Now someone will ask me, hey, do one thing, tell me, let's say my manager is coming to me and saying, hey, can you tell me what is a P90? No, let's figure out P, not P90, let's figure it out P95. So you tell me P95, what is that? Percentile 95, what is that?
6 second.
7 second.
Yes, correct.
Yeah, so
6.
sorry, sir, 6 second, you're correct, yeah, 6 second. So this means this is the 5% remaining, correct now? So that means remaining 5% people have the response time more than 6 second, which is 7, 8, 9, 10, it can be anything. So that way it's creating a benchmark how much of total people, let's say your expectations are my software should be response time is 6 second. So that means your P80, sorry, 5 second. So your P80 is 5 second right now. That means 20% of traffic is having more than 5 second. That is not a good number. Correct now? Maybe you're expecting is my software should be loaded in 5 second. So that means only P80 you have a 5 second. That means P80 5 second. That means 20% of remaining traffic is having the response time more than 5 second. Now you need to find out why these 20% people is having the response time 5%. Is it a software issues? Is it a code issue? Is it infrastructure issue? Or maybe some other region? Are you understanding?
Yes. So
Little
it's
bit different.
obviously the 95 mean. So the last 5 percentage of transactioning
we are ignoring. We are trying to find out what the exact top value of 95 percentage.
Yeah.
Like top
So
value. If it is 95, yeah.
yeah. So this table which you see is automatically populated. So now if you see that here, you have a value P50, P75, P90, P95, and you can see that. Right now, not variance is there because traffic is very consistent. So that is the reason. So you'll have to understand this way. Now there is a one more algorithms which we have, and that is called Apdex score. So I would like you to look at it little bit carefully. This is the Apdex score. So what is the minimum and maximum value for Apdex score? Can you please tell me? Hello?
Minimum is
In this graph, right? You are asking.
Yeah, yeah, in this graph only.
I think minimum is 0.
And maximum?
Uh, Maximum is like 0.8 above or 0.5
One.
something. Maximum. Yeah,
one.
Huh.
correct.
So Apdex score is this one. And this is the Apdex score range. So you understood from this table and this graph, the Apdex score has to be there between the 0 to 1. Correct? Now, agree with me?
Yes.
And this is the score, uh, and here is a timing. Now, question is what exactly the Apdex score is and how it will benefit you. That is a question. How it will benefit you. So, first of all, Apdex score is a customer satisfaction parameter. How? Let me show you just a second. So, if I go to Apdex score image, so whether your client is satisfied with your applications or not satisfied, that will be this. Why is not opening? Not sure why it's not opening. It's okay. So whether your client will satisfy with your application or not, that will be decided by your score. So tell me one thing, my score, if you look at it, my score is 0.74. So tell me my 0.74, whether it's happy, my customers are happy or not happy. What exactly?
Okay, okay.
It's a fair.
Fair, right? That means my customers are okay. I mean, fair. I mean, it's not very good, not excellent, not but not even poor also, and not even unacceptable. So right now that is the kind of thing. So if you are coming between this, your customers are happy. If you're coming for this, good. If you're coming with this, fair. If you're coming this, poor and unacceptable. Now the question is how this get calculated? How this calculated? So now in order to understand this logic, you need to understand some of the stuff. Okay, now, okay. So let's understand these slides now. Okay, so here, so guys, let me ask you one thing. If I make a request and then I got the response, so can I represent this response time? It can be in second or millisecond in hour. Are you okay, all of you? Hello? Hello?
Yes.
Okay, now you are the owner of this application and you might have done the capacity testing, capacity planning testing, right? Load testing, performance testing, you might have done it before the releasing the software in the market. So when you have done it, Just give me a second. When you have done it, then who will tell me if given a certain traffic, what would be the response time? You will tell me. The owner of the product will tell me that number, correct? Owner of that product. So can I represent that response time in the T? Are you understanding? Can I represent that number in T? Okay, great. So guys, in short, R represents the real response time of the customers. Just a second, guys. No. Yeah, sorry. So R represent the real number of traffic, and T represent the your expectations, expected response of time, response times based on your testing and your best development practices. Okay, so that is something. Now you know what? All the traffic, what tools will do? All the traffic where R is less than and equal to T, that traffic, that people, they are putting in the bucket called satisfy bucket. Okay, that is the things. Now those users where the R is greater than T, those people are being kept in the tolerating bucket, and those people who's having the R is greater than 4x of T, those people are putting in the bucket of frustrated. That means these people are frustrated, these people are tolerating, these people are satisfied in that duration, 1 hour, 15 minutes, 5 minutes, 10 minutes, whatever it is. Okay, so are you okay with this graph now?
It is little bit not confusing, but it is. I think we need tea break.
And just give me 5-10 minutes, I'll just finish this one. So R means real response time, very simple. T means the one is expected by the developers. All the traffic where the R is less than and equal to T, those people, those request client is satisfied. R is greater than T, tolerating, that those people are tolerating with your application. And where R is greater than 4x of T, those are people are frustrated with your application. Simple bucket. That you will not do that. Okay, the tool will do that actually. Are you comfortable now, all of you? Okay, so if you understood this one, then your formula for the Apdex is equal to satisfied request plus by tolerating request by 2 by total number of requests. That's the formula. So let me apply this formula for the scenarios where you have a satisfied request 100%, 100 people, 100%. So that means if you have 100% thing, 100% satisfied, then tolerating request 0. And if you see the Apdex score is 1. Whereas if you have a 0% satisfied request, 0 tolerating request, that means everyone is frustrated. That means your Apdex score is 0. So now what is my Apdex score? What is my Apdex score? 0.75. That means my customers are okay, not happy, but not bad also. So this will represent the customer satisfaction index. This is called customer uh, satisfaction index, like that. This is the one. So if you want to know what is your customers are happy or not, this way you will come to know. This graph will tell you whether your customers are really happy or okay or not okay, what exactly. So this will tell you. So right now I'm okay. I mean, my customers are not very happy but not sad also, not frustrated also. Are you understanding now, all of you? Hey, hello.
We have to go through this one like.
This by the way, this you cannot do anything. These are the fixed graph. It's a real data represented in this. You cannot change this graph. Here only t, here you can change it. So here default is set 0.5. That's your t, that's your value. You can change this one, but automatically this will be populated. So while troubleshooting, in order to find out the issues, these are the graph will tell you about your applications. So you got to know latency, historical latency, distributions, and by version. And here you got to know Apdex score also. So any questions on these two graphs, all of you? Okay.
If you would have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.